Hi my friend, how are you? Welcome to Joystick. And in this video of Joystick, we are going to solve the gold mine problem using dynamic programming. The problem statement of which is quite simple and it is a very interesting problem to solve using dynamic programming technique. So let's move to the problem statement straight away and understand what this problem is. You are given a gold mine which is nothing but a matrix of n into m. So this is a gold mine problem, but that gold mine is represented by a matrix of n rows in m dimensions. Now each cell of the matrix contains the cost of gold placed at that part of the gold mine. So we have a matrix, okay, which represents a gold mine. So in gold mine there will always be gold, okay. So each cell of this matrix represents the cost of gold available at that part. Now the problem statement comes. All you have to do is collect the maximum gold from this gold mine or find the maximum cost of gold from this matrix and also determine the path, okay, which you took to find the maximum amount of gold. All right, now you are going to ask me, okay, this is so easy. I'm going to add up the cell values of the entire matrix and I'm going to come up with the maximum gold. It's not so easy because we have a condition which adds flavor to this problem. What that condition is, we are going to see now. The condition is you can only move either right, all right, or diagonally up towards the right direction. That means right up diagonally or right down diagonally. All right, that means you can either move right, diagonally up in the right direction and diagonally down in the right direction. Okay, so here is our gold mine. Okay, here is our matrix. Okay, and as you can see, so if you are standing at this particular cell, then you can either move right, okay, diagonally up this way in the right direction and diagonally down this way in the right direction. This is what the condition of gold mine problem says. Now these arrows indicate that you can start from any of the rows of the first column. Okay, all right, so now we are going to move to the framework and determine the algorithm to solve this gold mine problem, and we'll see what is the maximum gold that we can collect out of this matrix and the path which we are going to take to get that gold. Before we move to our framework, if you are new to my channel, just hit the subscribe button and hit the bell icon too, because that way you will get notified whenever I release new videos on dynamic programming as well as other algorithms and computational problems. And in case you have any doubt related to this gold mine problem or other dynamic programming problems, you are welcome to comment on this video and I promise that I will answer your comments within 24 hours. So let's move to the framework and solve this problem. Here we are at our framework and here is our gold mine, which is nothing but the matrix. Okay, now these are all the costs of gold at each cell, and you can also interpret that as different positions in the gold mine. This is our problem matrix and we are going to fill our solution matrix to find the maximum gold. Now we are going to start solving this using dynamic programming technique. So I'm going to start from this cell and let's consider this as our first sub problem. Okay, so if our matrix contained only this cell, then how much gold could we have collected? So it's going to be 1. All right, now moving to this cell, or you can say this cell in problem matrix, then how much gold can we collect? So it's going to be this 5 plus this 1, so I'll get 6. Moving to this cell over here, so how much gold can we collect? So it's going to be 12 plus 6, so it's going to be 18. But wait a minute, there is something I'm missing here. Okay, and I want to share that with you. All right, now the condition told us that we can move right, diagonally upward and diagonally downward. All right, so this cell, okay, to calculate the value of this cell, we must have taken into consideration the value of this cell as well, because from here also we can move here. All right, we can move from here to here, okay, but from here also we can move here. That's, we are moving diagonally upward, but we are not taking this cell into consideration while computing its value. That means we are doing something wrong here. We are going in the wrong direction. So let's eliminate this, okay, and try to take this direction. So we are going to do the row wise computation, and let's check the direction we are going in is the right direction or not. So moving to this cell, what is the maximum gold can I collect at this cell? We cannot move down from here to here, so the only gold that is going to come in our pocket is going to be 2. That means we will have to start from here. That is the simple thing. Okay, now at this cell, how much gold can I collect? The value here is 0. It's 0. So let me tell you once again, we cannot start from here because we are not allowed to move down, hence we are not adding them up. If we are going to collect 0 gold, then we are starting from here. If we are collecting 2, then we are starting from here. Similarly, I am going to put 3 over here. Now since we are doing a row wise computation, hence we are not going to break that chain. All right, and we are going to move this cell. Now we can reach this cell from here as well as from here. Okay, so what is the value going to be when we are moving from this cell to this cell? It's going to be 5 plus 1, so it will be 6. All right, now let's consider this case. If we are coming from here to here, so what is the value going to be? It's going to be 2 plus 5, so that will give us 7. Now since 7 is greater than 6, so I'm going to put 7 over here. Cool. All right, now let's consider this cell. There are going to be 3 cases now, because you can move from this cell to this cell, you can move from this cell to this cell, but you can also move from this cell to this cell. All right, 3 directions as per the condition. Okay, let's see what happens when we move from this cell to this cell. So it's going to give me 4 plus 1, so let me put 5 over here. Now if I move from this cell to this cell or this cell to this cell, so it's going to give me 2 plus 4. The answer is going to be 6. Since 6 is greater than 5, so it's going to be 6. Okay, now let's move from this cell to this cell. So what is going to be my value? 0 plus 4, so that will give me 4, which is not better than 6, so 6 stays here. Simple. All right, move to the next cell. Okay, let's consider the value from here. So it's going to be 2 plus 6, 8. Let me put 8 over here. Great. If we move from this cell to this cell, then it's going to be 0 plus 6, which is not greater than 8, so 8 stays. Okay, now moving from this cell to this cell, so it's going to be 3 plus 6, so that gives me 9. 9 is greater than 8, so 9 comes in here. Okay, now at this cell we can only enter from this cell or this cell, so it's going to be 0 plus 0 if we enter from this cell. So let me put 0 over here, or if we enter from here, it's going to be 0 plus 3. So 3 is any day greater than 3. I'm sorry, 3 is any day greater than 0, so I'm going to put 3 over here. Okay, we are going fine. Now here we move here. All right, so we can enter in this part from this cell or from this cell. So it is going to give me, if we enter from this cell, it is going to give me 12 plus 7, so it is going to give me 19. Now if we enter from this cell to this cell, it is going to give me 12 plus 6, that is 18. Now 18 is not greater than 19, so 19 stays here. Cool. We move here. All right, so at this cell we can enter from this cell as well as this cell. Okay. All right, so if we enter from this cell, it's going to give me 7 plus 4, which is 11. If we enter from this cell, it is going to give me 6 plus 4, which is 10, and it is not greater than 11, so 10 is not counted. Okay, it is omitted, 11 stays. And if we move from this cell to this cell, then 9 plus 4 is going to give me 13, which is greater than 11, so I put 13 over here. All right, now let's compute the value of this cell. So from here it's going to give me 4 plus 6, so the value will be 10. If I enter from this cell, then it is going to give me 4 plus 9. Okay, 13 it gives me, and 13 is any day greater than 10, so it gives me 13. If we enter from this cell to this cell, so 4 plus 3 is going to give me 7, which is not greater than 13, and hence 13 stays. Moving to the last cell, we can enter from here or here. So entering from here is going to give me 9 plus 0, so that is going to give me 9, and entering here is going to give me 3 plus 0, that is going to give me 3. 3 is not greater than 9, so 9 stays. All right, we have completed our matrix, okay, this way, and we have done justice to our problem, to the condition that was provided in the problem as well. The only thing that we need to do is traverse this matrix and find the maximum value. So I can see, and you can see also, that 19 is the maximum value. So let me highlight that. All right, so this is the maximum gold that we can collect from this gold mine. Okay, now let's trace the path. Okay, the path which we are going to follow to reach 19. Now, as you know, we are going to stand here. Okay, and let's check from where we are getting this 19. So the value here was 12. We added 12 to 7, and that's how we got 19. So 7 is going to be in our path now. Okay, now from where are we getting this 7? Are we getting it from here, or are we getting it from here? Because we can get this value from either here or here. So obviously the value here was 5, value here was 2, so we got 7 from this cell. So it comes under our consideration. All right, so this is the path. So the path is going to be 2, okay, then 5, and then 12. This is our path. Okay, so if we are going to start from here, move diagonally up and then right, we are going to end up getting maximum gold from this gold mine. Now let's quickly check out the algorithm. So this is the algorithm. Mij is going to be Gij, that is our problem matrix. Okay, G represents the gold, plus maximum of Mij minus 1, Mi minus 1, J minus 1, and Mi plus 1, J minus 1. The time complexity of this dynamic programming solution is Om into n. So with this we have come to the end of this video. Do give it a thumbs up. I look forward to help you with programming and algorithms. Goodbye until the next video. Thank you.